and it's getting recorded.
Oh.
Yeah. It can't really hear you guys unless you jump in front of it. Like also I put a microphone on. Because when I'm not right next to it, it can't hear me. So I put a microphone on. And so it can't hear you unless you stand here. And so if you're writing on the information board, a lot of times I'll pause it if a student's up here. But sometimes you guys like to be in it. But I mean, it's not like a replacement for being in class. Being in class is the best thing, but if you're ever sick for like a week or you're sick for like 3 days, I know there's people in my house right now who have a fever. You can go into Schoology and you can see a video of the screen from class. And so this slide will tell you the assignment for the day. You can get the bell work and you can see what we worked on. So I do record it on most days. Sometimes I forget. So if you guys ever see I forget, you can let me know. Sometimes I choose not to also. Anyway, today's my first day. I'll upload it into Schoology and get our Schoology folder organized. So the only thing you have to do for bell work today is to write the golden rule of algebra. What you do to one side of the equation, you must do to the other. And that comes from the golden rule of life or something, where you say treat other people how you want to be treated. But this is math class. So I'll give you a little preview about what we're doing. We're doing one-step equations. So the golden rule, what you do to one side, you must do to the other. We're doing inverse operations. Right, this is addition. So we'll subtract 5 on both sides. We will show work. And if it's a fraction, like you'll have this with fractions, hit that calculator, and you get x equals 45. So that golden rule is where I'm subtracting 5 on both sides. So that's an example of what we're working on today. And by the end of the week, your equations will be longer. You'll have to distribute, do multi-step equations. So I know you might feel like, oh my gosh, I'm tired of doing those short equations. They do build up pretty quick here this week. All right, so now you have kind of a big challenge. And I'm pausing the recording for this because it's going to take a while. Does anybody need anything from me? Any help with anything? All right, on page 2, what's it about? It's a nice chart, isn't it? Yeah. Average daily freshwater use. It's about freshwater use and total population. With your people that you're sitting next to, make some observations about the freshwater. And then number 2 says, go ahead and write a conclusion about freshwater in the United States. So it does say here, work with a partner. So this is talk about it. It doesn't have to be like you in silence. Go ahead, chat about it. Write down a couple of notes about what it shows.
Increases every 5 years.
Yeah, every 5 years. Yeah, it goes by every 5 years. But I'm assuming the red one is like the population and stuff. The red one. So after 5 years, it goes to 50. The population of fresh colors of water goes down 50.
Have you been on here before?
We're still on page 2, right? Which one?
I guess it's, yeah, the population increases by population level for water increases.
And what are two conclusions can you make about water sources with effort in the United States and only? Well, I think that turn out not to they meeting or they meeting small. Okay, okay. Next one they are going to be a bus stop.
That's all. I think that's what I'm supposed to say. Well, this is a part, so that's important. Yeah. What conclusions can you make about the conclusions? Well, like 1985, or not 1985, 1980 has the most water use, but people have to population.
What observations did you make?
In 1960, there was 170 million population, and that popular. I agree.
I don't think so. I think we're in the labs and the
Just actually a 905.
and then we got 9:15.
I think so.
Yeah, I don't let people either. I'm about to have bathroom breakfast. All right, in 1960, the population was approximately 170 million, and in 2015, our U.S. population is more like 325 million. Good. So you figured out population from the red line. The red line was the population. Good observation. Let's hear another observation. Somebody else. Let's go to the back there, Diego and Gabriel. Did you guys make an observation? Is that your name, Gabriel? Jimmy. Diego and Jimmy.
I made the observation that in 2015 is the lowest usage of water.
Yes. So when the population was highest, there was the lowest water usage. You think 60 is a little bit lower? Oh yeah, 1960 does. But it was trending downward. We can say water usage trending downward. generally. It's lower than kind of in the 80s, early 2000s. So, do you guys have any ideas how the U.S. went about? When I was in school, we talked a lot about preserving fresh water. I don't know if you guys still do. How do you think we, even though our population is growing, how do you think we're using less fresh water? Like scientists got to work with business makers and the government and tried some different things so that we use less water. What have they tried? Yes.
I thought they raised the water bill since the population stepped right now.
Recently our water bills are higher. So do you think people are choosing to use less water because it costs more?
That's what they say, like, the water bill, but the faucet still have to make sure it's shut tight.
Yeah, shut your water droplet thing, shut it tight so it's not dripping all day. The toilet's not running all day. Some people like our dishwashers now. If you go buy a dishwasher now compared to 20 years ago, it says on there water saver or energy saver. Our technology is more efficient, so it doesn't run as much water. Our faucets, our toilets, our fridges, even though we got a lot of fridges that shoot out that cold water, we're actually utilizing less. The technology paired with the goal of the scientists and the businesses, and now our toilets use less water when they flush, but they're still efficient. So, long story short, we could say in the US, I think technology and other efforts are reducing water usage. And to be honest, the water bill has gone up. You guys get yelled at probably for taking showers that are too long. It's a big problem in my house. We have to set a timer. Get a left shower. But oh my gosh, there was actually a complaint in the government. It didn't get a whole lot of news, but they were complaining that the shower heads weren't like strong enough. And it was because of like there was policy about how much gallons of water a shower head can shoot out every minute. And they reduced it. And people in the government were like, this is a free country. Like, I want a shower head that's shooting tons of water. And other people were like, no, we have to conserve it. Like, you can't just use whatever amount of water you want. So that was actually a legitimate debate about should we be allowed to use whatever shower head we want, or should there be regulation on it? Good question. Is water considered a renewable resource? And I do encourage you to carry this over into science class, but fresh water, we used to talk a lot about like conserving it. Like you could only water your lawns with fresh water on certain days. You couldn't do it every day. The issue is as it becomes more and more polluted or when there's droughts, it becomes an issue. But I guess more recently we're more concerned with flooding than droughts, aren't we?
I mean, it is a renewable resource, but I thought it was used more to like they can use the water thing to turn into energy.
Oh yeah.
I mean, plus the water is not going over.
It's in the water cycle.
Yeah, we've been
Yeah.
having this at the time.
Right. A lot of it we do get from underground though. And the water table's changing with climate change. So yeah, all good comments. Very good. All right, let's flip the page. And I want to underline just a few different properties here. What page did I just flip to? I flipped to page 7. The addition property of equality and the subtraction property of equality are shown here. And these are things I think y'all are good at already. But there's some nice examples here in your book. This is a one-step equation. We're trying to get x alone. I see subtraction here. So to undo the subtraction, I add to both sides. Nice example there. And here, this is an addition equation. I want to get y alone. How do I get y alone? I will subtract 2.8 on both sides. So we're going to jump right over to the assignment because I know you guys have seen these examples before. And we're going to head to page 13. And I'm going to shorten this. I said 1 through 22, but we're going to do 1 through 21 odd. And I'm going to do like 4 or 5 right now. I'm going to show work. And you guys can do exactly what I do, or you can work at your own pace. If you want to work more quickly than me, then you do all 22. If you want to just do what I do, that's okay also. Yes. Yes, if you don't finish 1 through 21 odd, you're taking it home. You're finishing at home. All right, I'm gonna skip around a little bit. What time does this class get up? 9:00. Yeah. Gosh, that's not very much time. You guys, let's shorten this to every third problem. So watch what I circle. I'm gonna do 3, 6, 9, 12. I'm doing multiples of 3. 3, 6, 9, 12. I'm doing 15, 18, and 21. So tomorrow, I'm going to just have you open up to this part of your binder, and I'm going to see how many you got done. And I hope you attempt all of them. It's one step, and I will show the work and the answers tomorrow. So yeah, I wasn't sure just how long this would all take us. You guys did a really good job ripping out pages, by the way. Like, in years past, we've torn things to pieces, so very good.